The sand slips through your fingers almost like dry smoke. It leaves only a thin layer of fine dust on your skin. You stand in the middle of a vast desert and look toward the horizon. There you see the towering silhouette of the Burj Khalifa piercing the sky. It is a monument to human ambition and endless capital. It stands as a testament to the belief that engineering can conquer any geographic limit. Dubai sits on an ocean of sand. It has billions upon billions of tons of it stretching across the dunes. Yet the vast majority of the sand, right under the feet of this city, cannot be scooped up and poured directly into the concrete spine of those massive skyscrapers. It is the ultimate paradox of modern construction. A city built entirely on the promise of endless growth is starving for the one material it seems to have in infinite supply. Many videos on the internet will tell you that desert sand is simply too round. They claim the wind polishes the grains until they cannot stick together. That explanation sounds perfectly logical, but it is only a tiny fraction of a much larger and much more complicated truth. The problem is not just about the shape of a single grain. The problem is about how millions of particles smaller than a pinhead behave when they are packed together. It is a problem of fluid dynamics and extreme pressure, and the most incredible twist in this entire story is that the engineers behind the Burj Khalifa actually did use desert dune sand. But understanding how they did it reveals a hidden fragility behind Dubai's booming tourism and real estate machine. Dubai is a city engineered to defeat nature. It is a machine designed to pull millions of international tourists out of the sky and place them into climate-controlled luxury. The entire economic model relies on a perpetual state of expansion. Hotels must be built to accommodate the record-breaking airport traffic. Retail spaces must expand to capture visitor spending. Premium real estate must be constructed to attract foreign wealth. If the construction stops, the illusion of unstoppable momentum begins to fade. But this relentless drive for taller and more spectacular structures places an immense burden on physical materials. You cannot build a skyscraper out of marketing brochures. You need millions of cubic meters of structural concrete. When a tourist looks at the Dubai skyline, they see glass and steel catching the desert sun. But beneath the glass is a massive skeleton of artificial rock. Concrete is the second most consumed material on Earth after water, and sand is the critical ingredient that makes concrete work. So it feels completely absurd that a city surrounded by endless dunes must go to extraordinary lengths to secure construction sand. This paradox highlights a deep vulnerability in the city's foundation. The local sand represents a massive supply chain failure disguised by extreme wealth. The issue is not that Dubai lacks sand. The issue is that Dubai lacks the specific type of sand willing to take responsibility for a towering skyscraper. Nature provided the quantity, but the construction industry demands a precise specification. To understand why the desert fails the specification test, you have to understand what it takes to build a super tall structure. People often call concrete artificial stone, but before it becomes stone, it must behave perfectly as a liquid. Building a tower that reaches over 800 meters into the sky is an exercise in extreme material logistics. You cannot mix concrete at the top of the building. You must mix it at ground level and push it upward. This means the liquid stone must be pumped through steel pipes. It has to navigate through narrow valves. It has to endure immense mechanical pressure from massive industrial pumps. It has to climb hundreds of meters straight up against the brutal force of gravity. During this entire journey, the mixture cannot fail. It must flow easily without resisting the pump. Yet it cannot be so thin that the heavy rocks sink to the bottom and the water rises to the top. If the components separate inside the pipe, the entire pumping process comes to a catastrophic halt. The concrete must remain a perfectly cohesive gel until it reaches the highest floors. Only then is it allowed to set and harden into an impenetrable structural core. This delicate balance between a flowing liquid and a strong solid depends entirely on the internal friction of the mixture, and that friction is controlled by the sand. This is where the endless dunes of the desert begin to reveal their hidden flaw. We need to completely change how we think about concrete. It is not just a pile of random rocks and sand glued together with cement. Concrete is a highly advanced mathematical packaging system. Imagine you are trying to pack a suitcase with rigid objects. If you fill the suitcase only with large bowling balls, you will have massive amounts of empty space between them. To pack the suitcase efficiently, you need baseballs to fit between the bowling balls. Then you need golf balls to fit between the baseballs. Then you need marbles to fill the remaining gaps. This concept is known in materials science as particle size distribution. In concrete, the gravel forms the main skeleton. The coarse sand fills the large gaps. The fine sand fills the small gaps. The cement paste then coats everything and glues the structure together. An optimized distribution curve creates a dense mixture with very few voids. Fewer voids mean you need less cement and less water to achieve maximum strength. Desert sand completely fails this basic requirement. Wind is an incredibly effective sorting machine. Over millions of years, the wind lifts and carries away the lightest dust. It leaves behind the heaviest rocks, but it pushes a very specific, narrow size of sand grain across the dunes. Because the wind acts like a natural sieve, dune sand is remarkably uniform in size. It is almost entirely composed of extremely fine particles. If you try to build concrete using only desert sand, you are essentially trying to pack your suitcase using only tiny marbles. The particles are too small and too similar in size to create an interlocking structural grid. The mixture will have massive void spaces. To fill those voids, you would need an absurd amount of cement paste and water. This creates a weak and unstable material that is highly prone to cracking as it dries. This brings us to the most famous myth on the internet. You have probably heard that desert sand is useless because the grains are too round. The story goes that river sand is angular and locks together like puzzle pieces, while desert sand acts like smooth ball bearings. This explanation is incredibly satisfying because it is easy to visualize. But it is only a half-truth. Shape and surface texture do matter. Smooth and spherical grains do reduce the internal friction of a mixture. But having round grains does not automatically doom your concrete to failure. In fact, in some highly engineered mixtures, having a certain percentage of round particles actually helps the concrete flow better through the pumping pipes. The real enemy is the combination of the round shape with the extremely narrow size distribution and the microscopic fineness of the grains. When sand is both incredibly fine and perfectly uniform, the total surface area of the particles increases exponentially. Every single grain needs to be coated with cement paste. A massive increase in surface area demands a massive increase in water and cement to keep the mixture workable. Too much water destroys the compressive strength of the concrete. Too much cement generates massive amounts of heat during the chemical reaction, which can cause the building core to crack from the inside out. Therefore, desert sand is not banned from construction simply because it is round. It is restricted because too many of its characteristics are concentrated in the exact wrong places for standard structural engineering. If desert sand is so problematic, how do we explain the greatest architectural achievement in the city? The engineers behind the Burj Khalifa did something that seems to contradict everything we just discussed. If you look at the published technical papers regarding the massive raft foundation of the Burj Khalifa, you will find a startling detail. The concrete mix design explicitly included desert dune sand. They did not just use imported materials. They went into the desert, collected the sand, and put it directly into the foundation of the tallest building in the world. This fact is often ignored because it ruins the simple narrative that desert sand is entirely useless. But the truth is much more fascinating. The engineers did not just scoop up the sand and use it as the primary aggregate. They used it as a highly controlled variable within a complex chemical recipe. The foundation mix utilized washed crushed stone sand for the bulk of the fine aggregate. This provided the angular shapes and varied sizes needed for the structural skeleton. Then they introduced the fine desert dune sand to fill the absolute smallest microscopic voids in the matrix. The dune sand was not the main ingredient. It was a specific tool used to achieve a very precise density. To make this work, they had to use advanced chemical admixtures. They used superplasticizers to maintain a liquid flow without adding excess water. They used fly ash and silica fume to control the heat of hydration. The Burj Khalifa does not prove that you can use desert sand freely. It proves that you can only use desert sand if you have the wealth and technology to force it into submission. It took rigorous laboratory testing and relentless quality control to make a supposedly free material safe to use. Let us imagine what happens when you do not have that level of control. Imagine a standard high-rise construction site in the middle of the city. The developers are under massive financial pressure. They need to finish the hotel before the winter tourist season begins. The real estate market is highly competitive, and delays cost millions of dollars in lost revenue. To save money, a contractor decides to use a cheaper concrete mix with an improper ratio of unwashed desert sand. The concrete mixing trucks arrive at the site. The massive diesel pumps roar to life. The liquid stone is forced into the steel pipeline heading up to the 50th floor. At first, everything seems normal, but deep inside the pipe, the improper grading of the sand begins to cause a silent crisis. Because the sand is too uniform and fine, the mixture lacks stability. Under the extreme pressure of the pump, the water and cement paste are squeezed away from the heavier rocks. This is known as segregation. The lubricating layer of paste disappears. The coarse gravel and the fine sand grind directly against the steel walls of the pipe. The friction skyrockets. The concrete slows down and then stops entirely. The pipe is now blocked by a solid plug of dry rock and sand hundreds of meters in the air. The pump continues to push, building explosive pressure behind the blockage. There is no dramatic building collapse. There is just a sudden, deafening silence from the pump, followed by a logistical nightmare. The entire pour is ruined. The pipes must be dismantled and cleaned manually. The structural integrity of that section is compromised and must be demolished. This is why engineers do not trust the endless dunes. A single blocked pipe can destroy a construction schedule and bankrupt a project. This physical reality exposes the hidden vulnerability behind the glossy tourism brochures. Dubai projects an image of effortless luxury and boundless possibility. The marketing campaigns sell a vision of a city rising organically from the desert sands. But the technical documents reveal a much more complicated and industrial reality. Because they cannot rely on the desert, they must rely on an enormous invisible supply chain. The city must source its construction aggregates from massive quarries in the surrounding mountains. Mountains of rock must be blasted with explosives. The boulders must be transported by fleets of heavy trucks burning massive amounts of diesel fuel. The rock must be crushed in giant industrial machines to create artificial sand. This crushed sand must then be washed with precious fresh water to remove unwanted dust and chemical impurities. Sometimes, marine sand is dredged from the ocean floor, which requires an entirely different process to wash away the corrosive salt. Every single step in this chain consumes massive amounts of energy. Every step generates carbon emissions. Every step adds significant financial cost to every hotel room, every shopping mall, and every luxury apartment block. The tourism sector is highly sensitive to global economic shifts. When hotel occupancy drops or real estate demand cools down, the immense cost of this supply chain becomes a heavy burden. The city is trapped in a cycle where it must build spectacular things to attract visitors, but building those things requires importing and processing millions of tons of basic materials. The skyline is not a miracle of the desert. It is a product of a relentless, energy-intensive logistics network that remains completely hidden from the tourists snapping photos at the Dubai Mall. Up to this point, this seems like a localized problem about a specific type of sand in the Middle East, but the struggle to find the right sand is actually a warning sign for the entire global economy. The world does not lack the material we generally call sand. The world is running out of the specific types of sand that meet strict engineering standards. The United Nations Environment Program estimates that humanity consumes roughly 50 billion tons of sand and gravel every single year. It is the most extracted solid material in the history of the planet. We use it to build highways, airports, hospitals, and homes. We use it to manufacture the glass in our windows and the silicon screens on our mobile phones. Because desert sand is largely unsuitable for structural concrete, the global construction industry relies heavily on river sand and lake sand. River sand has been shaped by flowing water. It has the perfect angular geometry and the ideal distribution of large and small grains. But mining river sand has devastating ecological consequences. It destroys aquatic habitats. It alters the flow of water and accelerates coastal erosion. As cities around the world continue to expand at unprecedented rates, The demand for premium construction sand is outstripping the natural supply. We are depleting riverbeds faster than nature can replenish them. The irony is profound. We live on a planet covered in massive deserts, yet we are facing a critical shortage of usable sand. The global construction machine is incredibly hungry, and it is incredibly picky. So what is the future for cities built in the desert? Will advancing technology ever allow us to use the dunes directly and freely? The short answer is yes. Desert sand can be saved. But the more important answer is that it will never be free. Researchers and materials scientists are developing fascinating new methods to utilize desert sand. They are creating new geopolymers that do not rely on traditional Portland cement. They are using advanced synthetic resins and alkaline liquids to bind the fine grains together. Some companies are experimenting with heating desert sand to extreme temperatures to fuse the grains into larger artificial aggregates. Others are using 3D printing technology, where the precise application of chemical binders can turn fine sand into load-bearing architectural elements. But every single one of these technological solutions comes with a catch. They all require processing. They all require complex chemical additives. They all require massive amounts of electricity and thermal energy. To use the free material surrounding the city, you have to spend significant amounts of money to alter its fundamental properties. You have to process it until it no longer behaves like the sand you found outside. This is the ultimate economic friction. A city facing pressure from regional competition and changing tourism trends cannot afford to dramatically increase its base construction costs. Technology can solve the material problem, but it transfers the cost to the energy sector and the chemical supply chain. Why can Dubai not simply build its skyscrapers with desert sand? There is no single, simple reason. The grains are remarkably fine, the size distribution is incredibly narrow, the surface area demands too much water and cement. The mineral composition and hidden impurities vary unpredictably, and if used blindly, it will destroy the workability, strength, and pumping stability of structural concrete. But the most important lesson is not about the shape of the grain. It is about the illusion of abundance. A skyscraper cannot be built using the material that is most available. It can only be built using the material that can be mathematically controlled. Dubai did not build its towering skyline by ignoring the rules of nature. It built its skyline by meticulously testing and navigating every single limitation that nature established. The desert provides the vast, cinematic background for the tourism campaigns, but the engineering reality demands specifications, crushing plants, washing facilities, and rigorous laboratory testing. When you look at the city from a distance, it appears to have completely conquered its harsh environment. The skyline glitters against the barren landscape, projecting an aura of total dominance. But when you zoom in past the luxury hotels and the crowded airport terminals, the story changes. Every concrete pillar and every deep foundation exists because engineers understood that they could not trust the infinite ocean of sand around them. Nature did not try to stop the relentless expansion of this city with a catastrophic event. Nature simply presented a quiet, microscopic challenge. It provided a particle that was just a little too small. It provided a mixture that was just a little too uniform. In a city that operates on the belief that capital and vision can overcome any boundary, the ultimate reality check does not come from the financial markets. The ultimate reality check is a cold, calculated verdict, delivered on a tiny metal sieve in a material testing laboratory. If this documentary changed the way you look at the hidden mechanics of modern cities, please consider subscribing to the channel. We will continue to investigate the unseen supply chains and economic realities hiding behind the world's most famous destinations. The next warning sign is almost never where the tourism brochure tells you to look. This documentary is based on publicly available engineering papers, technical standards, and scientific research regarding concrete mix design. Material performance varies widely by source, processing method, and specific structural requirements. This video does not claim that all desert sand is unusable, nor does it imply that existing skyscrapers in Dubai are structurally unsafe. The analysis explores the economic and logistical pressures of urban development and is not intended as financial, investment, or travel advice.